Okay, good afternoon. So today we're building on what we learnt last lesson about secondary storage. We need to make sure that you can compare how much they store, how fast they are, and how reliably and easily they can be moved around for the three types of secondary storage. So magnetic, that's like a hard disk drive; optical, that's like a CD-ROM; and solid state, that's like your flash drive storage that you plug into your USB drives. Understanding that first bullet point is absolutely crucial for you to be able to do this, and this comes up in almost every paper 1 exam where you say something like a McDonald's delivery driver needs a handheld device to store orders. What type of storage are you going to need? And you'll instantly know why one is better than the other two. You are not allowed to use a calculator in your paper 1 or paper 2 exams, and that's good news because you're not expected to do difficult maths. Wherever you see this phrase, it means don't calculate, just write down what you need to write down in order to calculate it. So we'll do some practice of that as well. So we looked at the three, and we need to know how much it stores, how easily can it be moved around, and how fast it is. We've done that already. So let's have an example. Let's imagine it's small, that means it's portable. It's handheld, which means it's going to move around and you might drop it. And it's a video camera, which means it's going to store quite a lot of stuff. Students are going to use it. So it shouldn't be super expensive. What's the most appropriate storage out of magnetic, optical, and solid state? So on the VLE, you'll find this as P17. We're in half term 3. You've got a scenario. You need to name, that's optical, solid state, or magnetic, and justify. Give a reason, please. So yeah, sorry, we need to do question 1 as well. Find examples of capacity. Find examples of capacity for an optical drive that's like a DVD. This was an extension to one of our previous tasks. So you can give individuals, you can give averages, or you can give a range. So if you like, you can try and find the smallest and the largest, or the average, or just a range, whatever you like. Okay, so let's just have a quick look at activity 3. Remember, you are not expected to do calculations in your head. You are expected to write down expressions. So first thing to remember is how to convert between megabytes and gigabytes and all of that kind of gubbins. So if you ever see just MB, that means megabyte. We're doing Edexcel, which insists on doing things correctly but rather confusingly, which means a mebibyte, and they are different. So we need to remember this acronym. So I go for kick my granny to pieces. For killer, I said it wrong. Kick my granny to pieces. There we go. Killer, mega, giga, tera, and peta. If we're doing it the Edexcel way, it would be this. I don't know if this spells anything. I haven't ever tried it before. Tebi, and you don't even have to know about this. How do you pronounce that? Kaimgiti, which is why I prefer kick my granny to pieces, because it's violent and I don't recommend ever doing it, but it's easy to remember. It means kibi comes first, and there are 1024 kibibytes in a mebibyte. There are 1024 mebibytes in a gibibyte. There are 1024 gibibytes in a tebibyte. And then the exam questions don't go as far as a pebibyte, but it makes a nice acronym. You can also have a different acronym, something like Kit Kats make giraffes too podgy, if you particularly prefer. How does that help? Well, if we've got 1024 bytes, please bear in mind that a byte is a byte is a capital B, and a bit is a lowercase b. Stupid word, it tries to correct things. So there are 8 bits in a byte. There are 1024 bytes in a kibibit. There are 1024 kibibits in a mebibyte. There are 1024 mebibytes in a gibibyte. There are 1024 gibibytes in a tebibyte, and 1024 in a pebibyte. So what's the expression? Well, you'd get a mark for doing this in the right order. If we want to go from bytes to megabytes, we start with 1024 bytes. We have to divide by 1024 to get to kilobytes, and divide by another 1024 to get to megabytes. Oops, sorry, I got the acronym wrong, didn't I? So there would be 3 marks here. If you just wrote the answer, you're probably going to get it wrong. You are not expected to do this in your head. You will not have a calculator in the exam. The phrase construct an expression means write down what you would put into a calculator. I'm going to highlight this in different colours. The red is the number of bytes that we have. And then I've got to divide by the blue amount because I need to go from bytes to kilobytes. And I'm going to divide by the green amount because I need to go from kilobytes to megabytes. Does that make sense? You could have also written 1024 divided by 1024 squared, but that's a little bit harder for you to do because you've got to do the control shift equals to toggle the squared thing on there. But that is, hopefully you can see that 1024 times 1024 is 1024 squared. You don't need to write both. I'll do one more and then you need to do the rest. 10.8 kilobytes in bytes. So 10.8. If we need to get to bytes, all we need to do is multiply this time by 1024 because we're going from bytes to kilobytes. All of these increase by a factor of 1024 except for bytes is 8 bits. Okay, so a little bit of maths involved. Do not do the calculation. Do not write the answer. Do not work out what the answer is. Just construct an expression. I hope I've made that really crystal clear.